All right, I'm going to do some quick test review to get us ready for upcoming tests. So let me get through this, get to it. All right, so the first thing that we're responsible for are our forms of energy. All right, so first of all, let's define energy. It is really an ability to do work. And this is in science. When we work something, when something's work, we're applying a force, and there needs to be some kind of movement to it. And so usually when we have energy, there's going to be some kind of either a current ability or an eventual ability to cause the movement of something. And it may not be on a big scale. It could even be on a tiny scale, like on the scale of an atom. So again, the ability to do work has to do with moving things. And so anything that has energy or could have energy should fulfill this idea. We've got 7 different forms, and we went through this with our Mrs. Chen. So we had M and R and S. All right, so this was mechanical. We typically think of things moving as being mechanical. This was radiant. This was energy moving in the form of electromagnetic waves. Most commonly was light. But light is not the only radiant energy. And we also had sound. These are also waves, but they're going to be a little bit different because they need to have something to travel through. So these actually do need a substance, a solid, liquid, or a gas, to be able to move through, whereas light and radiant energy doesn't actually need that. If we go down a little bit further, we've got the second half, we've got Mrs. Chen. And so our C was for chemical. And this is going to be stored in the bonds that hold atoms together. So, for example, in a lot of molecules, big molecules, you might have a carbon held to a carbon by this invisible force, and that invisible force is a bond. And it took energy to create that bond, therefore energy would be released when that bond gets broken apart. The H was for heat, which is also thermal. All right. The E was for electrical. And the N was for nuclear. Now, heat and thermal is oftentimes it is the result of radiation, but it is oftentimes one of the things where that energy is being changed into, and it generally, once heat is absorbed by another material, it's going to create or increase the movement of that material. The electrical is going to be caused by the movement of electrons, like we see in electricity. And nuclear energy, we're going to find inside the nucleus of an atom, such as with nuclear energy. Okay. We also talked about that even with mechanical energy, that when things are moving, we can further define them as having kinetic energy and or potential energy. We usually think of something as having kinetic energy if it's moving, and if it's got potential energy, if that energy tends to be stored. When we define these by a formula, our kinetic energy was found by taking 1/2 the mass times the velocity squared. So in other words, for something to have kinetic energy, it needs to have a velocity. So it needs to have some kind of movement to it. That movement could be side to side, it could also be up and down, but it needs to have some kind of movement to it for it to have kinetic energy. For potential energy, our formula was these 3 things. So for something to have potential energy, again, it still has to exist, because that's what the M is for in both of these, but it needs to have the force of gravity on it, and this is for what we call potential energy due to position. Gravity needs to be able to push down on it, and the amount of potential has to do with its height. Okay, so if there is more mass in an object, it's going to have more potential and kinetic. If it's got a greater velocity, it's going to have more kinetic. And if it's at a greater height, it can have more potential energy as well. So an object can have either of these. It can have both at the same time. We saw a number of diagrams where we talked about an object falling. And so if an object is at the top, if it was in the process of falling, it would have both potential and kinetic. And the reason why is because it still has height, but if it's falling, it also would have a velocity. And so it would have each of these. It would have each of these until it got to the point where it hit the ground, because as long as it still has height, it still has potential energy. And as long as it has velocity, it has kinetic energy. Now what we would expect, though, is as something was falling, what we would expect is that the potential energy would drop. Why? Because the height is going down. And as it's falling, its kinetic energy should rise, and the reason why is it's because its velocity would be increasing. So there is a relationship between these two, and it's usually an inverse relationship with a falling object, at least, so that as one thing is going down, the other thing is going up. We also discussed the idea of total energy. Total energy was the kinetic and the potential put together. And what we tended to find was that the total energy would remain the same, because what would happen is if the kinetic energy goes up in an object, generally the potential energy would go down, and so that we find that the total energy in the system would tend to remain the same. So we looked at falling objects. We also looked at things like, let me erase some of this. We also looked at some things such as pendulum, which is kind of like a swing, the thing that was going back and forth. But anytime we've got an object that can go up and down, what we're going to find is a constant changing of its kinetic and potential energy. So if we have, again, a pendulum that's in multiple places, it's a really bad drawing. If this is the highest part, we would expect this to be the highest potential energy and the lowest kinetic energy. If it got down to the bottom, we would expect this to be the lowest potential energy and the highest kinetic energy. And then here in the middle, we would expect it to be kind of a combination of both, because it still has some height, but it also still has some velocity. Okay. And again, if we calculated the total should be equal in all places. So if we gave these numbers, let's say the potential was 100 here and kinetic was 0, then here potential might be 0 and kinetic might be 100, but then in the middle it might be a little bit of both. But in all these cases, if we add those together, we get 100. If we add those together, we get 100. And if we added that together, we would also get 100. Another thing for us to remember is that we have an energy unit. So when we're measuring energy, what we end up giving it to, the term we use for it at the end as for our unit is a joule, usually just abbreviated with the letter J. So anytime we see a J coming somewhere, that is an indication for us that it is going to be some kind of measure of energy. And I think that's kind of it for the first little section that we had there. So again, these are the types of things that you might see on your test to assess that, and this is our basic information that we have for it.